All right, this is our lesson on powers and exponents. We're moving on a little bit from adding, subtracting, multiplying, and dividing, and we're going to be looking at expressions with exponents and powers. So our objective to evaluate those expressions, remember, evaluate, get it down to one number. We're still not solving equations yet. There's no equal sign, but we are evaluating the expression and getting it down to one number. All right, so in your notes, you can be following along. We've got our basic setup is this 3 with the small 2. So we're going to identify what we call those two numbers. We don't call them big 3 and small 2. We do have more specific names for them. And so the base, you can fill that in on your notes, the base is the number that is used as a factor. And so the big number is the base. And the small number is what we call the exponent. I know that you've seen these before, but it's important that we go over them again. And so the exponent tells us how many times that base is multiplied. So an easy mistake that many people make is to do 3 times 2. Because we see a 3, we see a 2, and so we multiply. But it's not 3 times 2. It's 3 times itself twice. And so that would look like this. We'd have 3 times itself 2 times. 2 3s there. And that's going to give us 9 then. And so when we're using those exponents, the small 2, the exponent, tells us how many times we multiply that big 3, the base. How many times we multiply that together. Now these words that we have there, I'm going to go ahead and just go a little bit at a time. We do have some shortcuts, some ways that we say this. Rather than saying 3 to the second power, which is correct, it is 3 to the second power. And we use that power word to talk about the exponent. But if it's specifically a 2, we call it squared. And so the area of a square is s times s, which is s squared. And if you go ahead and please do draw this picture in your notes right now. Go ahead, pause it, draw that picture. So with that picture, if we look at a square, if we wanted to find the area of that square, as it says right here, we would multiply base times height. We multiply s times s, side times side, which would give us s to the second power. And so that term squared comes from the idea that we have a square and we're finding the area. And so when we see that 2, that power of 2, often it's referred to as squared. Similarly, when a number is raised to the third power, we say it's been cubed. And that derives directly from a cube. If you want to find the volume of a cube, you do the side times the side times the side. Length times width times height. The base times the height times the height. And so we've got s times s times s, which is s cubed to the third power. And we don't have a shape for a fourth power that we can look at. It's a hypercube. And so we would call that s to the fourth, but nobody would really say s to the hypercube. That would be really weird. So we say s squared for area of a square, s times s, a power of 2. We say s cubed for a power of 3. Moving on though, so that was some vocabulary. Part of your assignment and part of your pre-test, post-test, etc. will say write the power represented by this geometric model. So we've got this geometric model, this geometric shape, either 2-dimensional, 3-dimensional. And if you look, we've got we've got a cube. We've got this cube here, and all the sides are 5. So if we wanted to find the volume of that cube, we would do length times width times height. So we'd have 5 times 5 times 5. And I know, based on that last screen, that I can rewrite that as 5 to the third power, or 5 cubed. And we take that side length, and since it's a cube, we would have 5 cubed, 5 to the third power. And that, what I have circled right there, that's all you need to have. I don't need to see the 5 times 5 times 5. I'm writing it so you know where that comes from. However, you don't need to have that on a final answer for any kind of a test or quiz. For this, you just need to write 5 to the third power, or 5 cubed. Similarly, for the bottom, we've got a square. So if we were going to represent that as a power, the area would be 6 squared, or 6 to the second power. And that's all you need to write for those type of problems. Moving ahead here, a caution, big caution. red, yellow, all sorts of different colors. Let's be careful about this. Parentheses. Parentheses are very important, but parentheses are very specific. They make sure that we do things exactly right. So in this, we've got the example they gave is -5 to the second power, -5 squared. Now, you have to be very careful about this. If we look, -5 squared, and some of your calculators will do this correctly. -5 squared is actually different than parentheses -5 squared. We're going to look at why that is. -5 squared, as it says up here, if you have just -5 squared without parentheses, 5 is the base, because the negative sign is not part of that base. It's not in parentheses. And so that first one, this one right here, -5 squared, the negative is not part of the base. So we're going to, and you can't see when I cover it up with my hand, but we're not going to care about that negative sign when we're doing our exponents. We're just going to do 5 to the second power. We're going to do 5 times 5. And that negative sign is still out in front. And it's still out in front right here. But 5 times 5 is going to give me 25. However, that negative sign is still out in front. So the answer is going to be -25. So without the parentheses, -25. With the parentheses, now the negative is part of the base, which means we're going to do -5 times -5. Since we just went through multiplying with integers, multiplying with positives and negatives, a negative times a negative is going to give us a positive 25. Different answers. That negative does make it, or excuse me, that the parentheses does make a difference. So the rule of thumb, the way you want to remember this, if the negative is in parentheses, the negative is part of the base. If the negative is not in parentheses, the negative is not part of the base, and it just stays out front. So that if there's no parentheses, and it's got a negative sign, it's always going to be negative. Okay. They did give another example here of -2 to the third power, where -2 is part of the base. I encourage you to try that on your own and see what you end up getting. Let's look at some expressions here. Now, I'm going to do a couple, and then I'm going to have you try some on your own. Again, it says to evaluate the expression. So if you want to pause it and try it on your own first, feel free to, but I'm going to go through them here. So -6 to the third power, again, those parentheses are there. So it's going to be -6 times -6 times -6. I do not need you to expand it every time. However, you may not use a calculator at this point, and so you still need to be able to do this without a calculator. The numbers will be small enough that you'll be able to handle it without a calculator. So -6 times -6, if I do that first, I'm going to get a positive 36 times -6. I need to be careful of my mental math here. If you don't want to do it in your head and you're doing this as an assignment, I encourage you to do the little scratch work. I'm going to do some scratch work over here and see what you end up getting. And so when I multiply that, I get 216. It'd be -216 because again they have different signs, which gives it a negative answer, 216. That'll be my final answer for that. For the next one, we've got -10 to the second power. Again, I don't necessarily have to see the work shown. However, -10 times 10. Be careful. The negative is not part of the base. So it's not -10 times -10. -10 times -10, or excuse me, -10 times 10, -100. Last one here, fractions. Fractions look mean. They look hard. It's, oh my gosh, it's 2 ninths squared. What do I do? If we expand it, 2 ninths times 2 ninths. Well, we've done multiplying with fractions already this year. And so multiplying with fractions, we multiply the numerators. 2 times 2 is 4. We multiply the denominators. 9 times 9 is 81. I can't reduce that. That's it. 2 ninths squared, 4 81sts. And that's how we use exponents with fractions. Give these three a try on your own, and we'll see what you come up with. So pause it, and then we'll go through them together. I'm going to assume you paused it. So you should have tried these on your own, and we're gonna fill in then. So the first one, -5 times -5. times negative 5. My 5s look a lot like S's, but you'll have to forgive me. And so negative 5 times negative 5, I'm going to get a positive 25. Times negative 5, I'm going to get a negative 125. Again, you can work out the arithmetic there on your own. Negative 6 squared for B. Again, we've got a negative, but it's not part of the base. So we end up with negative 36 as our final answer for that one. For C, 3/4 times 3/4 times 3/4, 3/4 cubed. So we got 3/4 times 3/4 times 3/4. 3 times 3 times 3 is going to give me 27, not 9. Remember, it's not 3 plus 3. It's 3 times 3 is 9, times 3 is 27. And we've got 4 times 4 times 4. 4 times 4 is going to give me 16. Times 4 again is going to give me, oh, now I got to think for a second. Yep, 64. And so your answer, 27/64. We don't have any negatives to worry about for that one. Okay. Last one here. So I'm going to do one of these, and then I'd like you to try one on your own. I'll do A. It says, write each number as a power of the given base. It's a weird way of writing it, and it's a weird way of asking a question. What they're looking for is, if we know the base is 8, if we know the base is 8, and we know the answer is 64, so they give us the base, and they give us the answer. We got to figure out what number, what exponent would go here. What would you put for an exponent? Well, 8 times 8 is 64, so I know that 8 squared would have to be 64. So write each number as a power of the given base. Your final answer would be 8 squared equals 64. So they give you the solution, and they give you the base, and you got to figure out what would the exponent be to make that happen. So for B, I'm going to have you try this on your own, where they give you the base, they give you the solution, so you have to write an equation that uses that base, negative 3, and has a solution of 81. So I'm going to go ahead and pause it, try it on your own. I'm going to assume you paused it. So again, that base is negative 3. We don't know what the exponent is, and we know the solution is 81. All right, so let's think here. We know it's going to be 3 times 3 times 3 times 3, etc. So 3 times 3 is 9. And, oh, I'm sorry, the base is negative 3, so the parentheses. Got to have parentheses. The negative is part of the base. It's in parentheses. So negative 3 times negative 3, positive 9. Times negative 3, negative 27. Times negative 3 again, positive 81. So the solution is going to be negative 3 to the 4th. And you can work that out on your own to make sure that I did it right. But negative 3 times negative 3, positive 9, times negative 3 is negative 27, times negative 3 a 4th time, positive 81. I believe that's what we have for that. And so you can go ahead, turn this off, do the pretest, and good luck today.